Well, hi there. We're glad you're with us for this interesting discussion. I'd also like to let you know, in case you were unaware, that we do have a weekly newsletter. Comes out on Wednesday, one time a week. Does not flood your inbox. And there's also the BDR itself and radiolist.net, some mailing lists for professionals. We hope you'll make use of these if you have the need. And if you would like, look at that little red button down in the lower right corner, subscribe. Become part of our YouTube live bunch. Thanks. I think I think the topic that we're going to talk about today is a good one because it gives us some thought as to what's coming. When I got started to radio, we had tube transmitters, tube preamps for the turntables, the the solid state amplifier for the Ampex was brand new from Jim Wood at Innovonics. And we didn't have CDs as yet. Some stations had cart machines. Um, some people had cassettes. And we've seen a huge change. Almost all of the audio is now contained inside computers. But the question that I wanted to raise is, will we get to a point where there's no hardware at all? And of course, you can't get away from the transmitter and antenna. Right now, they don't have a solution to remove those. So that's going to be with us for a while. But from the microphone to the transmitter, we're seeing less and less. And this is why I invited Bill Robertson from DASDEC and Christan Schneiring of Lawo to be with us and talk about some of these things, answer some questions. If you have some questions or some things you would like to know, feel free to put it in the chat box. You can raise your hand, and I'll find that and I'll call on you. Or I'm sure Bill and Christian will not mind if you carefully open your microphone and ask a question at the right time. About 15 years ago or so, I was in Chicago, and it was not the first time I had seen a radio station in a cage. But at WLS, their FM literally was in a chain link fence square about 3 foot by 3 foot, and that was their whole radio station. And a lot of stations have gone full automation. And you say, well, why do they even have studios anymore? And so that becomes a real good question. At the NAB show last spring, several companies were showing us virtual racks where there was software driving everything from preamps and amps to audio processing. And therefore, you didn't really need much in the way of hardware. Now, I'm going to start with you, Bill, if you don't mind, Christian, because DASDEC has done something that is a little different in terms of getting the EAS into the transmitter instead of having a separate piece of equipment in the rack. And what's the phrase you use? EAS ready or
EAS at the edge?
EAS at the edge. So please give us a quick thumbnail. For those of you that don't know, again, Bill is the president of Digital Alert Systems, where the DASDEC comes from. And you may also want to say something about this $1 million fine on Charter that popped up today. But go ahead and dig in.
Well, first of all, I'm not president, I'm vice president. So thank you for the step up. I didn't see it in my paycheck. So anyway,
it's one of those promotions where you don't get any more money. You just
yeah,
get glory.
That's exactly right. I wanted to pivot just on one of the things that you said very early on in this, and to bring some of the things in context, is that we still have, and the reason that we call it EAS at the edge, and the premise of that is that these edge devices that, if you will, they're the transducers between the analog world and the digital world. So, for example, you mentioned microphone. Microphone is a transducer that converts, analog pressure waves, if you will, longitudinal mechanical waves into an electrical signal. On the other side of it, a speaker is the same thing, where it's taking, the reverse of that, taking an electrical signal and converting it into a longitudinal mechanical wave, audio. And we see that in the television space also. A camera, a sensor, you have to have that to capture the image. Once you've got it digitized, you can do all kinds of things with it in our current space. And that's what's neat. Audio processors that you talked about, some of the image processing, other things that are capable, but then you still have to take it to the output, which is a display. So those edge devices that bridge the analog into the digital world are still a kind of a requirement. And what, in our context, we looked at this and said, what is the necessary part for alerting, and our specialty in this kind of alert sense type of stuff is we needed to have that edge device, which is our DASDEC unit as representing listening and getting the alert information. And then we can convert the information that we have to send out into a digital form. And what we did with that particular thing is try to look at, okay, what is the signal type? What is the best way to do that? And the signal type in that context is one that is AES67, which means it is a audio signal that is around an IP type of wrapper. So you can digitize audio, you can make PCM audio, you get AES3, which is essentially PCM audio, but it doesn't have any wrappers around it to how to move it through a IP type network. And that's the neat thing about AES67 is it gives us that wrapper that we can put it through an IP network. Now, what we did is we incorporated that with a routing protocol so that we can say, we're not just going to pipe it down an IP network, we're going to have a destination target for it, and we're going to use a routing protocol to make sure that unlike a regular EAS system that would be in the middle of the air chain or at the end of the air chain and switch away from program to the alert information, if we're on the one edge of it, we need to make sure our signal can emanate all the way through that air chain, no matter what switches are set, no matter what faders, no matter what other processing is going on, to make sure at the end point we can assert ourselves and put that alert information out so that we usurp the regular program audio and put the alert on. So what we're doing is kind of jumping from one edge and doing the decode logic and everything we need to do here, converting it into a signal type that we can move through a network and put it on the other side of the edge and say, now play this at this particular point. So that's really kind of the context of having the two edges of the ability of the input and the output where it makes the most sense, and using a format that is compatible across this IP type of network.
Do you foresee this turning into no hardware at all, just software anytime soon?
Well, again, it's that same thing. I can't virtualize a microphone. I can't virtualize an antenna. I need to be able to receive those. And one of the things around this is if we look at the idea of radio as a fundamental system, as we have had with EAS, and supporting that. I mean, we are in the broadcast business, and it makes really good sense to have radio and TV as a backbone for the public. A lot of people say, oh, we'll just do iPods. Well, guess what? iPods doesn't carry every alert. Also, iPods is based on internet. And if the internet fails, oh, wait a minute, does that ever happen? If the internet fails, how are you going to get the signal to the end? Broadcast, and this is the thing that gets me too, is if I were a emergency coordinator, I would not put all my eggs in one basket. It's not all about, hey, I want to put it on the cell phone or I want to put it on TV. You should cover as many bases as you possibly can. The likelihood that you're going to get the message through is far greater the more of those types of layers that you build into it. So you don't just say, oh, I'm only going to alert cell phones, or I'm only going to do this, because then you run the risk of having a failure that could ultimately create all kinds of problems. So I think there are some elements of this that again can be virtualized, but not in the entirety.
Okay, so that means still for the short term there will be at least one little interface box that's necessary somewhere in the plant.
Yep, exactly. I think Harold's got his hand up.
He does. Go ahead, Harold.
Yeah, so it's interesting as to where you draw the line in this. The interface box you're talking about sounds like it has receivers for local alerts and then another computer in there. And I wonder about moving everything except for the receivers into the network. Perhaps a program automation system could include EAS decode, EAS encode, and so on, simplifying the outside hardware. There is still the issue of FCC Part 11.34 and certification of equipment, and when you move it into program automation, it becomes interesting.
Harold, you're absolutely right. And there, again, people have commented to us, and we can do elements of our device right now. We do it in support of levels of virtualization, but we're cautious. We're very cautious about saying, how far do you go with that? And let's look at those things, because the other thing that you have is we've got a very, very dedicated, process that's going on. You just don't want to hand this off into an automation system that may not have, sufficient, processing horsepower, or we guarantee in the method that we do our decoding and things like that, that we're going to have the resources that we need at the time we need them. So there can be a lot of these little nuances about that, about, taking it. And again, if you put it in a receiver context, what do you do with the receiver? I want to be at the point where you demodulate. I don't want to have to demod and then re-encode it into maybe MP3 that's a lossy format and then try to transport that. Then I've got to dedicate, bits and bytes for a transport stream. To us, it makes more sense that we're at the very, very closest edge we can possibly be to be able to do that and have dedicated, processing that isn't going to be impacted by something else. So you've got a good point, and we've discussed this in a couple of different forums, even NAB radio forum and things like that, about what has. It's just that general, let's make sure we're not just jumping into this thing in this particular thing and saying, oh, technically, is it possible? Sure, we could look at some of the things around it. Does it make sense completely? Let's be a little cautious as we move forward.
I suppose it's no secret that the DASDEC is basically a computer with relays hung off it and software.
Mhm.
Canada has I would say, is it shareware or is it free? Or they have a whole software system up there that does not appear to rely on any hardware.
Well, actually, all of the radio TV guys, for the most part, in fact, all the cable guys use our equipment and everything else like that. So the requirement is in Canada, they don't have the radio side of it. So there's still a lot of processing that goes on, and there are tremendous, in the United States. I don't know if anyone's ever looked at the CAP Canada protocol, but they've got event codes for, and I'm not exaggerating, wild dog packs, ice flow warnings. We talk about things like tornado warnings here in the United States, or things like that, but they have a whole giant range of that. They also don't have dedicated FIPS codes in the same way. They use a different kind of designation that can be modified by census. So there's a different way in which these things are put together, but it doesn't require that phone or the antenna demod stuff. It relies on that. So there is a company out there that is kind of open source that they have it, but I've not seen a lot of people take it up because there's a lot of support. There's a lot of other things that come into play and being able to do that. And by the way, there's a lot of same kind of things that we have here in the United States where they change things. They're adding this, they're doing this, they change this, and you got to keep up on it. And that's part of the whole thing too.
Well, FEMA made some changes this week, and as a result, on Monday there was crickets, right? I kind of know exactly what happened, but I don't know that I don't want to embarrass somebody at FEMA, but let's just say it failed.
Yep.
So, uh, I'd like to talk a little bit further at some point, maybe after a few minutes. Let's bring Christian in, but I'd like to talk about separating EAS from a national system to local, and what can be done to overcome the mandatory status at one point and the cooperative status on the other. So I'll just feed that into your mind, and we'll come back to it. Christian, uh, one of the things I saw a couple years ago was your relay uh, application, which is essentially a console in a box. How
Right.
would you how would you describe it? Christian, tell us first of all,
Who I am here.
you're with
I
Lawo.
wanted to start with expressing my gratitude for the invitation today, Barry. I appreciate that I can be part of this group and to speak from Lawo's perspective. For the ones who do not know Lawo, and I saw in the attendees list, there's aside my colleague Joe, who's lurking around here somewhere. I see Ed Schwartz. Ed, great to see you again. Ed, in his previous life with SiriusXM, we worked together, so he will be my instant correction if I say something wrong. Thank you, Ed. Joking. So who's Lawo? I just want to spend here a second on this for the ones who not necessarily have heard about us thus far. We are a German-based company and a technology provider in a more global sense, audio-video world. We're offering solutions in a wide range from live sports, think World Cups, Olympics, to all the way into radios, into radio stations. Mentioned at here, SiriusXM as an example. Myself, I'm Christian. I'm based in Toronto, and I'm overseeing the radio arm, the radio business for Lawo here in North America. So yeah, I'm happy to be part of this group today to talk about how we see where radio is. And I wanted to start maybe by saying that I do remember a few years ago I had a conversation with several people who mentioned to me saying, Christian, I really believe radio is dead. And I asked them why, and they said, well, with all of this jazz around self-driving cars and data and cell phones, I rather see people watching their favorite Netflix show in the car on the way to work rather than to listening to podcasts and radio stations and live talk in the morning. And I'm very happy that from my perspective, that is not true. So I think very much radio is not dead. Yeah, so from a Lawo perspective, on the radio side, which is one of our arms that we serve, we have a wide range, as I said, from software only relay, and I'll get to that in a second, to I call it a little more professional in a sense that there's consoles with dedicated hardware. And what we see when we think about or when we see radio stations in the past, I recall and I see there's a lot of purpose-built boxes. Boxes that do one thing and do that one thing very great and really well. And beyond that scope of that box, chances are you will need to buy a different box to do something different. And then came the exponential growth in compute power with servers, computers, and chips and all of that in it. So we looked at this and saying, how can a lot of these things be incorporated into software? And Relay, as you mentioned, Barry, here is one of our solutions, virtual radio, where some elements within a radio chain can be virtualized. We have a range of solutions for virtual radio mixing. That is exactly it. It's a virtual radio mixer that can run off of a Windows computer. You can tie in audio that is available on the computer as part of a virtual sound card. You can tie in Skype sessions or Zoom sessions as talk shows into one of those fader units and mix your own radio show out of the bag. Yeah, as you're clicking through this here, I appreciate it. Thank you. The virtual sound card is a multi-channel software application that allows you up to 64 streams to be available on your computer, and it's all software. ASIO device or WDM device drivers. And then the last thing that you haven't seen yet is the if you go scroll down once, if you click on where is it? Yeah, I can click there. If not, I can share my screen because I have it open here as well. Barry,
Go right ahead.
share screen. Let's see if that works. Can someone? Can you be my sounding board? Can you see my screen?
Not yet.
Not yet.
Click on the green button, then click on your screen, then click on.
Oh yeah, there's share. Sorry, I have to confirm. I apologize.
There it goes.
All right. So the suite of software applications that I talked about is the last one is the audio over IP stream monitor. One of the main concerns that we have listened to and that I still have conversations about, and it's a very valid concern, is once you have audio within a network, whether it is a private cloud on premise or if it's audio streamed within the more public cloud AWS, how do you keep control over all the audio streams? And how do you not lose focus on it? And how can you monitor, control, and quality control everything? The audio over IP stream monitor is exactly that. You can dial in all these different streams, AES streams, Ravenna streams, and basically display them here, and you get a direct feedback, again, all virtualized on a computer to handle the audio. So from our opinion, from what we see, it all depends a little bit on the application and the customer. Obviously, we have had conversations, or I've had conversations with customers who are very much on the forefront of all of this and are very interested in that pursuit of decoupling software and hardware. So banking on that idea of using common computers that you can buy at a hardware store, a Dell or HP, and then load software on it, all the way to smaller single entity podcasters who are saying, I need some solution very simplistic coming out of my backpack, basically out of my laptop. And in that suite, you can basically much address and scale almost all of these answers. So yeah, that is kind of a bit of an introduction. If you have a question here, Barry, a specific one, you are muted.
Sorry, had myself muted here, so didn't sneeze in your ear.
All
So
good.
it's software driven. So what
It
is
software driven.
what is needed besides that laptop and microphone?
In the simplest terms, a laptop will do. A Windows-based laptop will do. It is not Unix or Mac OS supported, so it needs to be Windows. And again, that's pretty much it. You have your microphone, you load your software onto the computer, similar to as you install a Microsoft Excel or Microsoft Outlook application. You run that software. Yes, an element, a form of license is required. And then you have your virtual sound card or your virtual patch bay running, and you configure your system. You save it as a snapshot, and even if you turn off your computer or you need to reboot your computer, all the work that you have put in is not lost, and it comes back up the way you left it.
Very good. So basically what you're saying is you really need very little interface. You just bring the microphone in and get going.
Essentially, yes. So in the simplest of all terms, you don't even need a external microphone. I've seen people use the internal built-in microphone of a computer if the quality that microphone provides is sufficient. But that's pretty much it, yes.
Oh, very interesting. Harold?
Yeah, so it comes down to an A to D and a user interface, which is real interesting. Some of this, especially the cloud-based stuff, reminds me of the idea that I had probably back in the 1970s when stations were putting in C-band receive stations, and quite often put them at their transmitter site because they had too much interference at their studio. And then they would run a link, audio link from the transmitter site back to the studio, insert commercials there, and then send it back up. And with the introduction of automation, I thought, well, let's just put the automation at the transmitter site and send spots up. We can do them, low speed through a modem or something, and we don't need to send all this audio back and forth. So I think that's sort of a primitive cloud-based system here, where you just send what you need. In the modern case, it's that microphone audio to the cloud, and most of the time there's nothing being sent. It's all being generated there, just as it was in my proposed reel-to-reel and cart system at a transmitter site.
Yep. It's sounds a little bit like a remote production, but it's exactly it. And then feels like you were maybe a little ahead of the time, because in today's world, where we don't necessarily have 64 kilobit modems anymore, it's all 5G LTE for the most part, depending on where you are in the country. Obviously, because we have different technology, underlying technology available to us as a vendor into that field, we can bank on that available technology to make life a little more streamlined for radio stations.
Very nice. Now, that's pretty much a standalone operation if someone wanted to operate that way. Now, you have some other radio consoles, I think, with the Crystal and the Diamond, if I recall.
Yes, we do. Hang on, so how do I operate my current share? Hang on, let me see. Because I have that. Can you still see my screen?
Yes.
Okay. So the suite of relay we talked about here a minute ago is all software solution, and that is the way how we anticipate where we are going. More software driven things, but there's still some elements of hardware. One of the newer console solution that we introduced last year at NAB New York is the new Crystal Clear, and it's kind of an element in between. So you have, similar to that VRX that we talked about a minute ago, a VisTool interface. It's software driven, again, runs on a Windows machine and provides you all self-driven, self-op, fader control, playlists, automation interfaces on a software, which essentially eliminates the space needed on a traditional studio where you have multiple screens, one for playout, one for the browser, and then you have a surface, a physical surface, and all these things. Now you can combine it all into one screen, and if that is even touch screen, that makes it even easier. But in applications where you need, I'll call it, let's say, more higher quality audio, then the underlying processing blade is something called the power core. Now that's still hardware. I understand this. Today that's the power core solution. It's a 1RU unit, FPGA based, and essentially provides you all kinds of I/O. I heard that phrase edge. We are using a similar term here. It's essentially the gateway into AES67. On the front of the unit, you see all RJ45 connectors for control, Ravenna, AES67, MADI, and on the back of the unit, you'll have 8 slots that you can plug in hot swappable I/O cards, whether it's an analog card, an AES card, a studio card, line out card, whatever, to connect your legacy products, your legacy units, for example, microphone, into the box, and then it basically becomes a digital console as the power core unit. It has basically the processing, the DSP capacity is within that 1RU unit. You can think of in all kinds of application, whether it's studio-driven, remote production was a topic that came up here a minute ago, where the power core sits in your rec room within the station, and you have your computer with the VisTool with you in your backpack here, and you're out on the field, and you connect to the power core via the internet, via VPN, via internet, and control via that platform, control the power core in some instances thousands of kilometers away. Not a problem. And then there's obviously always some users who prefer and like to kick it old school, run physical surfaces, and all of that is fine. We have that as well. There's two versions of it. One is called Crystal, and the other one is called the Diamond. I'll start with the similarities based from the new Crystal. This crystal here also runs on the power core. The same 1RU unit that I briefly described here is the same processing plate that sits underneath. And on the surface, then you have something like this here. It's a crystal board that provides you with physical elements, like a physical fader and physical knobs, physical encoders. And that comes in 6 or 14 faders, optionally with a screen, as you can see here in that little picture here. And yeah, that's one option if you prefer to go more physical, or you have needs to drive a radio studio with physical boards, and there still is need for that. And then if you want to really bring it up even one more notch and saying I need more flexibility, more scalability, and more dynamics in the size of the board, then we'll talk about something like the Diamond. Where is it? Up here. Again, same power core, different surface, pretty much the same components. Layout very similar, some slight differences, which I'm happy to talk about where need be. One of the big major differences that you can take away today is the Diamond is very modular. It goes from 2 faders all the way up to 16 faders per surface. So plenty of fader capacity for pretty much all instances, depending on what your needs are.
That's for sure. We have a question in the chat box from Reiner Johnson. He says, I think it's interesting, one system seemingly being more hardware-based, the other more software. How does this speak toward more items going into the cloud?
I think we're in a little bit of a transitional phase. There's some end users who prefer to have physical hardware for whatever reason, and some others who prefer to go into the software already. As it is almost on the edge of 2025, how I see things as we're moving ahead in time, next 5-10 years, I think you'll see a decrease in hardware and an increase in software.
Do you think the cloud is reliable at this point?
So are you talking on-site cloud, on-prem cloud, or public cloud?
Yes.
Both. Yes, it is. We have instances where we run on a public cloud. Yes, it is. The challenges that come with a public cloud is if you, depending on how much data you're running to the public cloud, the cost can go up quickly, depending on how much data you're sending up to, let's say, an AWS instance. Amazon will be very happy to invoice you this on a monthly basis. The question at one point is, where do you have that sweet spot of it is actually better to run your own on-prem cloud, put a couple servers into your rack room, 1 or 2. I mean, these if you look at the bandwidth and compute power a modern server has, you get a long way with one server. So then the question becomes, is that sufficient? And the answer in most cases, if I'm honest, is yes.
Well, that's where you come in to help identify what's needed and how
yes.
best meet those needs. I notice here on the Diamond, there are about a zillion buttons.
Yep.
And so question number one, I suppose that one up in the upper right-hand corner could be all the hot shots for the morning crew. Or are you able to do, say, a reset of the whole console as so far as in inputs by a button?
Yes, you can. And I'm not trying to sound too intimidating in my response here. The boards come with a standard configuration. Things that we've realized or we saw over a majority of projects we've seen worldwide, were things that are just needed in a radio studio. So you can basically, out of the box, you unbox your console and you're ready to go within 10-15 minutes. You can get on the air. Now, what the Lawo board provides, and that software that you see on that screen called VisTool provides, is it's a very customizable software that you can either learn to program. It's open to program yourself if you have engineering staff on hand that is interested in and wants to learn and configure it. You can always ask us to help. That's not an issue. But pretty much every button that you see currently on that console is completely configurable depending on what you would like to have that button do. And the other answer is, can you reload snapshots, production files of sorts? The answer is yes again. We have instances where, based on an RFID card an employee carries with them in order to get inside the building, to tab, to say I'm in the building and I'm basically my time is counting, the regular RFID tag or card you have, that RFID card can be read and basically read out saying this is a specific person's RFID card, and the console layout changes to that person's preferred layout. So if someone else walks into the studio and swipes their card, the complete layout, not the physical layout, obviously, but the software layout, what buttons do, that can completely change to the preferences of the host who's driving the board for the next session. But it is something that is, frankly, very, not everyone needs that. That's what I meant, but I'm not trying to be daunting here. Not everyone needs that sophistication of customization, but it is doable and possible within a Lawo board.
I would guess the Diamond is more designed for production than on air.
Both.
That
Barry,
custom.
Barry, so we, because they have the software interface, the Viz tool, we use these down at Sirius XM, and we basically created for the users a much more stripped down, simplified version of the console. So as Pierre pointed out, you don't get overwhelmed by all the buttons and everything. And we were able, through again their tool, to customize it to the point where, you know, the faders had the names of the common inputs that the users are used to seeing and whatnot. And the consoles themselves have snapshots on it. And again, through the Viz tool thing, you can actually give a snapshot, the name of the person who commonly uses the console, so they can just select their configuration. Because we also felt that you come in and look at this thing and it's like, well, the engineers smile and go, well, it's very simple. You have the on-off button and you move the fader up and down, and what else do you really need to know? So we created a version of this that got rid of almost all the knobs and everything else, because we had the same issue. Looks complicated.
The user customization thing reminds me of, I think years ago I heard of a car where each driver had their own key, and it would readjust the mirrors and reprogram the radio when you put your key in, which is a similar thing. And I can see in here, flip the microphone phase so that the person's voice properly modulates higher in the positive direction on an AM station.
Yeah, this is Pierre. Sometimes I think with you know, our toys and our consoles that we forget humans have to operate them. They have to have an interface that they can catch on real quick.
Agreed. Which is interesting enough. There's always two sides. There's you want to keep it as simple as possible to an operator, for an operator not to mess around, not to have the ability to mess around too much. While when you talk to an engineer who obviously loves all of these buttons and shiny toys and bouncy meters, again, something that can be controlled or can be configured within this tool. And you can actually have an instance where an engineer can remotely dial into a specific surface to say, I can help you if there's issues arise, without the engineer actually needing to get up and commute whatever distance it is to get to the operator. Best case scenario, it's next door. Worst case scenario, it might be far, far away.
You've
I
got
think
to be careful not to hide the suck button, though, when you put things way deep in menus.
Fair enough.
a quote that I think is attributed to Einstein is to make everything as simple as possible, but not simpler.
Well, I feel like some of our design engineers must be fans of Albert Einstein. Then, yeah. Yeah, it's effectively that is what it is. No one really likes to get those 3 a.m. morning calls on a Monday morning, to saying, hey, that button doesn't work, only to find out it is because of a very simple reason. So you try to build something that is robust and very robust and robust enough to not fail, but at the same time allows you a flexibility and sophistication to add more, because requirements and demands only go up on almost like a yearly basis. So if you have that flexibility that you can build on what you have, whether it's a new feature, because it's all now software, so that makes it much simpler than an FPGA box, purpose-built box. Whether you can add functionality over time, because that's what is needed, without changing the operator's perspective and relearning all the tools from ground up.
Hey, Barry. One thing I'd probably add on some of the stuff that Christian has said too is that there is really kind of a difference between cloud operation and virtualization. So understanding the difference here, you can have a small station and you don't have to be in the cloud for that. You can do some things with on-premises type of equipment, as Christian kind of pointed out. And that's a little bit of where we kind of look at the idea of our EAS at the edge thing too, is it should be more on-premise, even linking these things to kind of maintain that if there is, in the event of, worst day scenarios, you can still get emergency messages through the system. So again, I like what Christian was kind of pointing out, but there's that subtle difference between cloud and on-premise compute power.
A very good point, and I'm glad you brought it forward there. So you can buy consoles that are very, very, very cheap, and sometimes the company makes furniture, or you can spend a little more and have a console that will be very adaptable and will be moving you into the future here of IP connected without having a tremendous server room to support it. So,
but Barry, one of the things that I found anyway was, to a certain extent, COVID sort of changed everything forever, at least from my experience, and that's, I think, although it was there before, the origins of remote operations of a console or broadcasting without ever actually coming into the studio anymore. Just before I left Sirius XM, we were doing updates of studios that had an older generation from another manufacturer no longer in business, and we decided in the end we were not going to fix up the studios. We were not going to fix the acoustics in the room, because quite honestly, nobody ever really comes there anymore. So we wound up putting 17 of these mix engines into a rack, and everybody accesses them remotely from wherever they are via the internet through whatever, security mechanisms. So we've set up, and well, nobody ever comes to the radio station anymore. And, it might be left over for desks for sales assistants and things like that. But the talent and the people, they don't come, even the producers, to do the call screening through tele systems, this and that, all remote accessible now. And like I said, it's when I saw today's topic, your question is, gee, do we even need to build radio stations anymore, or do we just need a couple of racks of mix engines or taking it to the next level, which I see manufacturers are heading to, not even hardware-based mix engines anymore, but just, virtualized applications running on processing. Somewhere we'll have to have a box with a card to plug in an analog source or something to convert it into an IP stream. But like I said, I wonder, if the future is we're not building radio stations anymore. A few weeks ago, if I could tie this in, when we had a gentleman from what was a Super Hi-Fi who had a whole automation system and essentially radio production system in the cloud. I just wonder if that's the future, and the radio station is a couple of business desks, if that, in some leased commercial office space.
A lot of it probably has to do with the budgetary constraints. And I personally look and see this crystal that 4 pots and then you have your headphone and a monitor. And that's all that many of these home studios need. If it's reliable, if it works, and it does what they need, well, now this is probably where a lot of stations are going. We had a major consolidator here in this city, had probably, oh goodness, 7 or 8 studios and 3 or 4 production studios, and they just left their location and moved. I've not been in there, but I doubt that there's more than 3 studios.
And the hardware is nice, but quite honestly, you can emulate all of that with a touchscreen, which is what we did in a lot of cases, because hardware is more expensive than a computer with a touchscreen.
Well, for some, that relay is probably the answer. And then for others who want that hands-on technical feel, the pots might be the answer. Harold, I see you're up again.
Yeah, I'm using the raise hand so I don't talk over people like last time. And this also reminds me of another group I'm in that does a lot of stuff with PA. And of course, there used to be mic snakes going back to a console in the middle of the room and all that. Now it's just a little DSP box sitting on the stage. All the microphones plug into that. Audio goes out to the powered speakers. And the sound system operator has an iPad in the back of the room controlling the DSP box over Wi-Fi. So things have changed.
They certainly have.
If I can just add to this,
Please.
On the topic of DSP box, on a little bit of a different product here, it's Lawo also has a range of products called audio production consoles. It's like a bigger brother of radio consoles. On that side, there is a UHD core similar to what the power core is as a processing plate. This is now available as software only. So now the DSP processing doesn't even have to be hardware anymore. I think the DSP processing now lives in on a server. So essentially, at the end of the day, all it is, you collect all your, as Ed pointed out, you have your gateway on the edge. You get all your legacy audio into IP, get it into the IV world in the network, and then you can do pretty much anything you want to do with it, even if it is the processing plate of an audio mixing console.
Well, I think that's the versatility is the key. You could take that relay and move your whole radio station to wherever you happen to be that day and broadcast from there.
Correct.
Anyone else have questions for Christian? Anything on the Lawo consoles or software? Well, if you are interested in getting some more information, this is his card. And Christian will be very happy to answer anything that you have in mind. And I've already invited him to come back sometime over the next several months. And let's do some live demonstrations with these consoles.
Happy to.
And answer some more questions.
Sounds great.
Okay. Bill, let's jump back to you for a minute here. EAS, as we know it, is a mandate for stations. They must have the box. They must receive the tests each week, and they must be ready for what used to be called the EAN. All the rest of it's voluntary. And
Actually, there's 4 codes that are mandatory. The EAN still remains. They just changed the name instead of emergency action notification to presidential message. So, but it still remains that. The other one is the national periodic test that you must do, the required monthly test you must do, and required weekly tests. And there's a slight difference in the RWT versus RMTs, but those are the 4 mandatory ones. All of the other ones are, as you point out, Barry, are voluntary. They are pretty much typically defined by the state EAS plan as recommended for that particular state. And it's kind of an important thing too, where if a state agency, someone that is going to originate an alert, has a pretty good understanding that people that are destined to receive that alert are capable of receiving the alert. In other words, if my state plan says that you should have a recommended thing is to have a radiological warning event code programmed into it, it's good to know that the systems in that municipality, that state, whatever the area, actually has that code active. So there's a real coordination, if you will, and an understanding that to start shutting these things off or to be selective about it. Well, I'm not going to do that. My management doesn't want to do this. I think, Barry, you've told the story too about they just want to shut it off completely and get rid of it. It's not a good public service. And the idea around this too is that a lot of this in EAS parlance is a public service. It's part of what, is the benefit of being able to leverage the airways and do things like that. Is the other side of this, the yin and the yang, is that you've got to, maybe partake in some of these things and be able to do that. So it is true that it's a voluntary thing, but it comes with a level of coordination that is important for the public good and the welfare of the messages getting out to these people.
do you foresee a time when the national and the 4 items are in a small box just for that, and then completely separate software arrangement for local alerts and information?
I don't really see that as separating, because the whole mechanism and the protocol and everything else is pretty much the same. If you've got one, you've got it for the others. There isn't enough to necessarily warrant separating them. I could definitely see, and this is something that I've advocated for quite a while. Right now, we do NPTs as a national event. So the National Periodic Test, as its name implies, is based on a national thing. But I this last year in 2024, we didn't do an NPT. I have a hard time as an engineer trying to develop something and looking at working on a system, especially as complex as this mean. In other words, there's a number of endpoints. We want to make sure those endpoints are properly receiving and whatever else we need to do that. When we only test it once every 2 years, it just doesn't make a lot of sense to me. I think one thing that we could do, and this is actually built into the protocol, be able to set up regional tests. So, for example, I could do the Western United States for an NPT, and just do the Western United States, and let's see what happens. Then we do, the Central, and then we do the Eastern United States as we go across. Get 3, and then do 1 test that's national in its scope.
That's your Halo product, isn't it?
Well, no, it's really just a case of using the protocol and just defining an area that we want to test. And if that's, at least then we could test it twice a year. We can find out, where did we miss? What wasn't set up right? All of the things that we want to do to test to make sure that in the event of when that real, bad day happens, that we can communicate. And that's one of the things around it. To the other point, Barry, too, there's an issue that I could definitely see moving forward. And this kind of comes down to a lot of the things. There's the pushback, and a lot of the people here in this group could offer even more into this thing. But the pushback is that there's a certain level of okay, I'm going to do a little bit of this, but I don't want to do too much, and I don't want to do self-reporting, or ETRS is such a cumbersome thing, because now the FCC says I want you to report, but then it takes them months to aggregate the data and generate a report, and you don't really see what's going on. And one of the problems we have with EAS, and even if it's IPAWS based EAS, as we're communicating to this, it's a yell. You just yell. You don't know who's in the room. You don't know who actually received it. You don't have any recognition. There's no feedback loop that's built in to EAS. And what's interesting is with these devices now, deployed as they are, and typically, they all, as required, they're hooked up to the internet to receive the IPAWS things, make them available to report, at least to some kind of aggregation point, did you receive this alert? And let it self-report. I mean, the idea that we could do this and be able to send an alert and get a recognition that it happened is really work. And that's really kind of the big things that we could do. We do it on our side with our Halo system. I think we did a presentation on Halo, but that's the whole idea, is the fact that I send an alert, and within a few seconds, I can find out that this machine, or all these machines, received it, and I've got instant gratification that, hey, I actually did something, or it did land where it needed to land, or it didn't land where it needed to land. And I think that's kind of a big thing around it.
I'm gonna say the PET stations, which were direct connected to FEMA, when they do a test to the PET stations, the PET stations report right back to FEMA if they got it or not. And one of the things that I felt that is missing from EAS that I think would make it more effective would be if they had essentially silent testing. I mean, every Monday, IPAWS sends out a test at 11 a.m. and everybody knows if they got it. And to Bill's point, there's no reason it can't report right back to FEMA that they got it, but it's silent. And that, for the rest of us on the screen, we don't have to look at a general manager or a program director who wants to know, why do you keep interrupting my programming for this EAS test? So the fact that silent testing and silent reporting is not built in is certainly something that belongs in the next generation of EAS, and I think that would make a major improvement in terms of understanding if it's working properly, if the message is getting out, if the message is getting back, without having to explain to every broadcaster why I need to interrupt your program.
And Ed, you're spot on. I mean, right now, we know when we receive the RWT that came in from FEMA, we don't forward it, because the idea is you don't want to make it interrupt. But if we could leverage that, and as a feedback loop, report it right back, it's possible. This is possible. We can seriously improve this. And really what we need is more people to kind of understand that. And the pushback, as I said, is a lot of it is they're concerned that the FCC is going to come down with a fine. That this is going to happen. Oh, if I don't do this, or if I do something around it, it really is something that could be done.
You are aware of the fine that Comcast was just hit with?
I think, was it Comcast or was it Charter?
Charter, sorry.
Yeah, you had mentioned about it. Why don't you say something about it, Barry?
Charter worked with digital alert systems to a degree, because they had several hundred EAS boxes, and they didn't get them all done by the December date the FCC had required. and the FCC hit them with $1 million fine.
Yeah, they're serious about that. And that, again, that's the other part about it is, you know, the concern that if you don't do it right, you're going to get fined, or if you're going to use it. I mean, some people were concerned that the whole ETRS was a plan to have the FCC look, and whoever wasn't reporting that should have been reporting, you know, that's their punch list. If I was a compliance person on that, I'd want, you know, go and use that as the first my strip sheet and say, okay, this station is in my market. They're supposed to report. They haven't reported. Where would I go visit? So there's some other things that are concerned about that too. I see Harold's got his hand up again, so
So I'm not familiar with your Halo system, but it certainly does seem that if this stuff doesn't automatically report to the FCC, at least it could report to you, and you would see what's going on with your equipment in the field. Silent testing, I think, is good, but now and then we need to know that the duck farts are really going to be broadcast.
Yep. And Harold, to that point too, that's why I'm kind of recommending the quarterly, you know, three things across the United States, and then once per year to do it. But again, it's so onerous. The whole ETRS mechanism, you know, when you have to do Form 1, Form 2, you know, within the 24-hour period, then Form 3, and all of these things, it makes every one of these tests such a huge effort that it's difficult to test more frequently.
Now, this is a competitor, of course, but do you have anything you'd like to add to the announcement from Sage that they're not going to make any more EAS boxes?
Are you asking me?
Yeah.
No, I mean, the announcement was abrupt. There's no doubt about it. It's kind of a surprise to many people. I think it really kind of showcases, you know, the fact that, I mean, if you don't monitor some of the things around it, and this kind of ties into some of the things, you know, we're in our third generation, so we recognize that certain parts might become obsolete. There's other elements that you have to come into play. So yeah, surprised is probably the only way to put it. And maybe surprised and at the same time not surprised.
Yeah, well,
Isn't-
I think the question is more, do you see a change? I mean, obviously, they're not going to build more of the existing box, but will we see them move to a more hardware, do you think? Or, I mean, I don't know if you know anything inside chatter, but usually competitors got to know. Or is
Well,
EAS built out and nobody cares
Well,
anymore?
I mean, you could try to read between the lines and some of the elements. It would be actually a lot better if Harold himself were here to wax on that. But it's really just a case of trying to, you know, keep up on it, what's going on. There are, as he points out, there are, you know, bursting or cyclical nature in some of the things that are going on with it, and you have to kind of do that. There's, you know, ebbs and flows naturally in business, and what's going on with it. There's things again where certain elements. I mean, we did a big thing. We recognized that we needed to move our tools to 64-bit tools for security purposes, for development purposes, everything else like that. So it means you got to change your platform and what you're doing based on you know what the requirements are today, and then what they may be in the future. So I mean, there are still other vendors that are out there, you know, with this type of equipment. But it obviously is a major hole then when someone like that just, you know, leaves the market in that respect.
I was thinking.
I
Go ahead.
I was in reading their announcement. I thought, and again, I certainly have no insight, but I thought it was basically the same thing. It's a hardware platform, and I'm not a manufacturer, but certain components are simply not available anymore. And rather than build or design a new box based on what we do today, I'm sure everybody's going, okay, what's the next thing you're going to do? And
Yep.
if you ever lock that down, I'll build something that will, work with the next generation and if necessary, be backwards compatible. But I think that's always a challenge, especially in this day and age, for any kind of hardware we're using in the broadcast station, is to try to maintain and buy components for things that were designed even as late as the early 2000s, and
Yeah.
try to buy them anymore. They're not made. There's something better. There's something different, but it is not a direct swap, with whatever is on the circuit board.
Yep.
That's kind of what led me to ask the question of trying to separate the national from the local to see if there's cost savings that can be made there at some point.
No, I really, again, the same things apply across the board. So you're not going to necessarily save anything. We have like a decoder only version of the DASDEC, our what we call the DASDEC 3EL, the entry level box. And the reason for the decoder only and the differentiation there is if you're a low power station, low power FM, low power TV, the requirements, the rules say you don't have to be an encoder decoder. You can be a decoder only. So part of the stuff that we have is that low cost box that doesn't have the encode logic. And it's something to try to keep those price points down as low as possible for the people that don't have the larger budgets or don't have the requirements to do that. So there's some other pieces like that.
How does the LPFM do a weekly test?
You can still generate an RWT. That's the one thing that allows it that you can do, but you can't generate any other event codes.
Okay, Harold?
It's amazing there's any cost savings in that then if you're generating the stuff. I mean, it seems like the only difference is software.
And that's true, Harold. With us, it's a software module to add the encode logic.
Okay, very good. Thank you.
Mm-hmm.
Any other questions that anyone has about EAS or DASDECs or something along those lines, or come back to the consoles?
I just wanted to make this comment, and I think a number of people on this group. So when I was with Sirius XM, we worked with FEMA and with the FCC because we offered them a mechanism to carry their national alerts across the satellite system. So I've sat in a room over at the FCC with a number of the people involved with emergency communication, and if you look at it from their perspective, they just have a mandate to be able to carry a national emergency message across the U.S. via every platform and every means available, and that's the way they look at it, and that's the way they're functioning. And interestingly enough, in the meeting I sat at, there were about 20 people in the room. I and one other person were the only engineers in there. Everybody else in the room was a lawyer, and mostly what they discussed was the reporting thing. How are you going to use it? What are the requirements? Who has to fill this out? And that was the focus of most of the meeting, as I sat there wondering why I was there at all. And when you begin to deal with regulatory agencies and these kinds of things, their focus is rarely on the engineering. It's always on, what is the mandate? What are the regulations? What is it we're being asked to do? The how you actually accomplish this thing tends to be, a couple of guys who have a good idea over there. So you have to look at sort of where all this is coming from. And while a lot of us can say, well, we can easily come up with 5 better ways to do this. As I said, you're really dealing with regulators and lawyers and attorneys who are sort of playing a different game. I'll just point that out.
And I think to your point, Ed, the real thing is that they're looking at it from a mission perspective. This is their mission. This is what they have to accomplish. And with our stuff, we looked at this, as I indicated. We're in our 3rd generation, and part of that is because we knew that if there's going to be part obsolescence or anything else like that, I mean the company's been around for the originating company with Monroe since 1955. So we've been doing different pieces and elements, and if there's a lot of those things that if you're going to continue a series, you got to look at it and say, hey, what do I need to do to re-engineer or engineer around an obsolete part or things like that. And that's one of the big things is having a lot of that stuff in-house, where our development people and everything else in-house can do that is another thing that really helps in putting a lot of this stuff together. So you understand, recognize what the mission is, recognize as a manufacturer what your mission is to help, to carry that water and to carry that particular mission forward. So there's a lot of stuff around it for sure.
And that raises the very same point that we were talking about with studio gear, that you should, as an engineer, owner, programmer, whatever, spend some time to identify what you expect out of the product and to get the one that matches your needs more closely than just buying the cheapest thing or the fastest delivery. I think I wrote a number of articles over the years, and I said, look, I'm happy to spend an extra $50 or sometimes $500, maybe more now, to get not only the right product, but the customer support that does not end up with a answering machine that no one answers.
There's a cost to that kind of stuff too, Barry. You're absolutely right. I mean, to have technical support and everything else that is available there, it does come at a cost, and people have to help understand that. So it's very much the sense across a number of different things.
Well, you guys have taken a big hit because the last upgrade last year was more than the alternative company, but you did more. You upgraded, as you said, from 32-bit to 64. You added features, and it was a one-time deal that you hadn't done anything in what, 10 years?
Oh no, I mean we've done a number. That's one of the things that has really been kind of an important thing for us. And I think, as we've talked about here today, is this idea of what can we do to build a feedback mechanism? What else can we do? We pioneered the trigger cap pulling in our version 4 software back in 2018. We actually had that in 2018. The changes to the rules last year were very disconcerting to us. We didn't want to change it. And the way that, and the reason for that is the fact that the FCC actually came in and dumbed down our implementation. They said, oh no, to make everybody, to do it, this is what we want done. And it actually took our implementation, which was much more sophisticated to be able to do things in a more unique way, and we had to dumb it down. That is not what we like. Is we like that, we want to innovate, we want to continue to grow and to build what, again, kind of borrowing from Ed's thing, a mission critical type of thing that we can supply and continue to supply and support. And that's one of the things around it is, right now we just released our version 5.4 software, which is as it's 5.4 or 5.0, that's our 5th release in that whole series. So over the course of the last 2 years, we've done multiple releases, continuous improvements, security enhancements. We've had a number of different things with some new sophisticated features. For us too, the thing that we have to be cognizant of on our side is not only the radio, but it's also the TV. There's a lot of stuff where we've added things like MPEG dash to be able to generate video output on our system in a dash format. We've added support for ATSC3 and the AEA, which is the Advanced Emergency Information. We've added a whole range of different unique things across all of these different areas. And again, that's why we continue to look at these things and try to innovate. The idea of I'd love to get together with FEMA and everything else and building feedback mechanisms and other things, and not just FEMA, statewide entities. If you looked at just a state SECC, they do a national, a monthly test. Wouldn't you want to know on a monthly basis that, did it propagate? Being able to do those things, which is really kind of an important thing.
I know it's not going to happen, but I think it would be really beneficial if the industry just stopped and looked at it, and bureaucracy aside, saw what could be done. You guys have made a lot of good changes in your software, and I think very few use the full capability.
Yeah. But hey, not everybody needs it all. I mean, and I do have to say, with taking one on the chin, is that people look at our box and tend to be they're afraid of it, because it is, there's a lot of nuanced things around it, and that's where people have this false sense that EAS is easy. We just need to do this, need to do that, until they get down to the meat of it. And the reason that our box has so much in it is because there are all these little nuanced elements that need to be supported, depending on the particular environment, where it is, what's going on with it. And again, we've pioneered things like our EAS net for box-to-box communication. We most recently announced that ATEM, which is one of the major video encoder companies, has adopted EAS net as their communications protocol. The EAS at the edge things that we developed for radio, we've been doing a different version of that for almost 10 years on the TV side. Where we can be on one edge, receive the alerts, and then get them into an encode chain that's further down, way far away from where the systems might be housed or anything else like that. So there is still room for improvement. There is a continuous ability here from our side to look and continue to improve and be there in support of our customers and be able to support the mission that is this idea of public alert and warning.
Very good. I'm going to put this up for folks that want to contact you directly. Christian, I know you're still there. At least I just saw you a minute ago.
Yep, still here.
You're going to be at NAB, are you?
Yes, now we'll be at NAB in Las Vegas.
Okay, and look forward to seeing what you're doing there and how it could benefit stations in this country to look just beyond the price tag.